All right, let's go ahead and look at the full quadratic formula. So here we have the full quadratic formula with our discriminant. And what I'm going to go ahead and do is go ahead and always consider doing the discriminant first. Remember, that's our b squared minus 4ac. That square root part. So I know about how many answers to go ahead and expect when I go ahead and do the mathematics behind it. And I'm going to show you several different examples, most of all because we are not using a calculator, and a lot of times our square roots are not perfect roots. So remember we talked about the fact that we might have to simplify. So let's go ahead and look right away at our first example. And example 1, I have 3x squared minus 8x plus 4 is equal to 0. First I want to make sure it's set equal to 0. This one is. And what I want to go ahead and do is I'm still going to work with my discriminant part. So let's say, okay, first of all, my A is 3, my B is negative 8, and my C is equal to 4. And we're going to go ahead and work with those. And I'm going to take care of my square root part first. So my discriminant, remember, is b squared minus 4 times A times C. I'm going to plug my numbers in just like I did last lesson. So I got negative 8 squared, and A is 3, C is 4. All right, and I'm going to go ahead and take care of that. So I have negative 8 squared, that will give me 64. 64 minus, now 4 times 4, 16. 16 times 3 is 48. And 48 minus 64 minus 48 is 16. Remember, that's 16, and it's the square root. All right. And so I have plus or minus 4, because the square root of 16 is 4. I'm going to put my rest of my formula in, so I have the opposite of b. Opposite of b, b is negative 8, so I need a plus 8. My plus or minus 4 that I got from there, I'm going to go ahead and erase the plus in the front. That makes no sense. Okay? And all of that is going to be divided by 2 times my a, and my a is 3. And my denominator, 2 times 3 is 6. So I'm going to have 8 plus 4 divided by 6, or 8 minus 4 divided by 6 will be my two solutions. So this has two real solutions, all right? And 8 plus 4 is 12. 12 divided by 6 is 2. And 8 minus 4 is 4. 4 divided by 6 is 4 over 6, which simplifies to 2 over 3. So my two solutions are 2 or 2 over 3. And all you have to do is get them. You don't have to do anything else with them. All right, example 2. First I'm going to identify my A is 2. My B is 8. My C is equal to 7. All right, I'm going to go ahead and use my discriminant part first. So I have b squared minus 4 times a times c, and 2 times 7. 2 times 7 is 14. 14 times 4, 56. So I have 64 minus 56. I'm expecting two real solutions here. And I have the square root of plus or minus the square root of 8, which we did earlier simplifies to plus or minus 2 square root of 2. All right. I'm going to put that back into my formula here. So I have opposite of b. So opposite of b plus or minus, and I have my 2 square root of 2 that I got, all over 2 times a. All right, a is 2, so I have a 4 in the bottom. all right? And my b is 8, so opposite of 8 is 8. Negative 8, sorry, I misspoke, all right? And so I have, in this case, something I can actually simplify. So before I do the math on here, I'm going to go ahead and show you a quick way of simplifying your fractions, because you will need to still do that. And I'm going to go ahead and instead write my 8 as 2 times 4. And let me show you why in a second. All right. That idea of a GCF still exists. So at the top, I have a GCF that I could pull out, which would be the 2 and 2 here. All right. If you gave me part of it, you'd get most of the credit. But if you can go ahead and simplify these, that would be fantastic. All right. Where I basically can go ahead and any place where there's a 2, and you should have 3 of them on the outside of a square root, they can all cancel. This leaves me with negative 4 plus or minus the square root of 2 over 2, and I can consider that done. And I have 2 real solutions. They're not nice ones, but as long as my square root is positive, I have 2 real solutions. And let's look at example 3. A is equal to 1, B is equal to 1, C is equal to negative 5. Let's see what happens. We're going to look at my discriminant first, so b squared minus 4 times a times c. B is 1, a is 1, c is negative 5. So I have 1 minus 20. Which gives me the square root of negative 19. And I'm expecting 2 non-real solutions. Let's go ahead and put all the rest of the quadratic formula together with it. And so I have the opposite of b, so minus 1, plus or minus my square root of negative 19, all over 2 times a, which is 1, so we just get 2, and you can consider this to be done. I don't expect you to do anything else with that. Example 4, this is the last example, so a is equal to 4, b is equal to 1, c is equal to 1. I'm going to look at my b squared minus 4ac, and b is 1, a is 4, and c is 1. So I have 1 minus 16, which is the square root of negative 15, plus or minus. Going to add the rest of that in there, so opposite of b, b is 1, plus or minus the square root of 15, all over 2 times a, so 2 times 4. So my final answer is negative 1 plus or minus, I left my negative off there, the square root of negative 15, all over 8. I'm expecting 2 non-real solutions. All right, so go ahead and work on the practice problems, and I will see you in the next video.